All right, let's continue our discussion about confidence intervals for proportions. And this time maybe we'll take another poll, 173 voters, and try to determine whether Mr. Jones has a chance of winning a congressional seat. And our poll finds that 52 of those voters say they will vote for Jones. And so the question we want to answer again is, will Mr. Jones go to Washington? Now, the correct way to do this would be, as before, to find all null hypotheses that would not be rejected by our observation. Unfortunately, in order to do this, we need to recalculate the standard deviation for every single one of these null hypotheses, and that's quite a bit of work. So we'll make one simplification here. For convenience, we'll use as our standard deviation a formula that looks very similar to our standard method of calculating the standard deviation, but this time we're going to be using our observed proportion as our generic null hypothesis. So substituting in our observed proportion, that would be 52 out of 173 voters, and so there's our sample proportion. We have our 173 voters that we polled, and we could calculate our standard deviation for that sample proportion by substituting it into the formula. We get about 6.03. So depending on what level of significance we use, if we use, for example, our standard 5% level of significance, then what we have is that if our observation is within 2 standard deviations of our null hypothesis, of our proposed mean, then we would not reject the null hypothesis at the 5% level of significance. So what does that mean? Well, with Jones, our observation, 52 out of 173 voters, that would support a mean within 2 standard deviations, somewhere between 52 minus 2 standard deviations, about 40 voters, and 52 plus 2 standard deviations, called about 64 voters. That's out of 173, however. So that suggests that Jones's support among the population is somewhere between 23% and 37% of the voters. And this is rather, unfortunately for Jones, an inconvenient interval because he does not have support of enough voters to win, at least assuming that he has to win 50% of the vote. Now, it's possible we might want to find those sample proportions and our confidence intervals directly, and we can do that using a little bit of algebra. So again, suppose I run our experiment and I observe k occurrences out of n trials, the k people who voted for Jones, for example, and if I want to express this as a confidence interval directly, it's going to be some number of standard deviations about our observed value. Now again, using our standard 5% level of significance, what we see is that our confidence interval is going to be the observed value plus or minus 2 standard deviations, where our standard deviation is going to be calculated based on the observed sample proportion. Now I can translate that observed number into a proportion using some algebra. So I have my interval divided by n, and so there gives me my proportion, and with a little bit more algebra, k over n is the observed proportion, that's our p hat value, and our standard deviation is going to be found using our sample proportion. I could substitute that in, and with a little bit of algebra, I'm going to move this n into the square root symbol, and I'm going to resolve and cancel it this way, and this gives me my confidence interval. So after all the dust settles, we find that our confidence interval for a sample proportion can be given by the observed sample proportion plus or minus however many standard deviations of our sample proportion we have, given according to a certain formula.